Well, my name is Rafael Mueller. I'm principal engineer at Cisco. I've been around Cisco now for about 21 years. So when I was joking about tokering, that was one of the first things that I worked with. So now these days I spend a lot of time on ACI with OpenStack and other integration models around ACI. So they asked me to come in and talk a little about implementation and deployment. I know we have some people that not seen a lot of ACI. I guess some others have. Anybody familiar with it? A lot? Very technical, low technical? Where are you guys at?
Heard about it?
Probably a little of everything.
Right in the middle? All right. So I think this is going to be an interesting session because you guys just talked about UCS Director a little bit and about how UCS Director can actually do some of this integration for you and automates that process of getting these services inserted into the fabric and everything like that. But one of the things that I've found over the years is that the past 2 years is the question sometimes comes as to what happens if I'm brownfield, right? Data centers in general, you know, they don't just, oh, we got something new come in. And when we talk about ACI and you're like, it's automatically, it's a whitelist fabric. So it means that you have to specify everything because if not, there's no traffic flowing. So how do you get there? How do you go from that point of saying, I want to integrate, I want to bring ACI in and I want to kind of implement it and bring it into my fabric and I have all this stuff here and I just, exactly how all that works is very complicated and difficult. So, you know, a couple of examples that, you know, happen in the real data centers of today is, hey, what's your application profile? And then the question is, well, I don't know. So Tommy had that thing, but Tommy left, and now there's 4 servers there, but I don't know exactly what they do. So how do we get there, right? How do we go from zero to this beauty of the ACI world? So we'll talk a little about implementation and also about you know, how to deploy it or how to get it in there. So some of these slides may seem, you know, very easy. It's just very difficult to talk about this. But a standard ACI deployment, there's a couple things in there. You've probably seen this is standard fabric, right? So ACI is unique in that aspect. All leafs connect to all the spines. Okay? So you guys have seen this a million times. So it's very, you know, it's something that you always have to consideration. So if you're doing an implementation, you're going to deploy ACI in your network, that's exactly how it has to go. There are the advantages of ACI integration is that it manages a lot of things for you. Has anybody here done VXLAN, like configured VXLAN by hand? No? Nobody's had the fun? No? Ah, okay. Well, then that joke will not gonna work. But anyhow, the thing is that VXLAN integration, when you start talking, you know, we talk about VLAN worlds and we talk about maybe 100 VLANs in a network, 200 VLANs. And we're going to VXLAN and we start talking about hundreds and thousands and hundreds of thousands of possible networks that you can put in there. Things get a little bit more complicated and you need something to assist you with. And ACI is definitely a good tool for that. The other thing that ACI gives you also is a lot of visibility into both the physical and the virtual of the network. And what I mean by that is that because we know what's going on under the underlays or on the fabric itself, we kind of compare things up of what's happening on the overlays to those underlays. Like match them together, which is a huge thing. And you guys troubleshoot in networking? And if you have something on top of it that has no conscience that that's what's underneath it, how do you troubleshoot it? Exactly. There has to be a marriage in somewhere in there. So, and that's one of the things that ACI, we say a lot about ACI, is that it's not only that you have an application that's running on top of this network, but the consciousness of what that application is and how it relates to the network that's underneath it, right? So if I have 200 switch leafs in my network, right, and I'm having a problem with a specific application, my application might not care if the leaf that's on a different part of the lab has a problem. Right? And if that consciousness exists on top of that, then the relationship isn't there. So ACI gives you that to some extent. So that's kind of what it looks like from the standard fabric. And the integration also, ACI, as you know very well, is fully 100% programmatic in its nature. All right. So from the ground up, ACI was built on top of the RESTful API. Now you might know where of this, but even when you do the CLI, you go to the CLI of ACI on a leaf node and you say show, I don't know, let's say show interface. What you're doing is you're actually talking to the RESTful API of the fabric and getting that information. It's not, it's 100%, it's the first Cisco product that is 100% API driven, okay? And that's really important because you get in that scenario like, how many of you guys have you seen previous implementations of Cisco of APIs for products where sometimes it's like, is the API, can I do this? No, it's not on the API. And ACI, anything that you do on the GUI is available on the API or everywhere, which is a huge thing. Then we get into the other possible implementation is the Stretch Fabric. Now this is where we want to position ACI from two different separate data centers. We want to be able to integrate it as one fabric, right? So it's one management domain controlled by the APIs, okay? And it's kind of a standard. I've put a really simple, easy scenario that we've supported since 103F, but it is implementation for that scenario of separating the fabric in two. And this is something that we continue to evolve. And we will continue to evolve because that's one of the biggest things of ACI, right? A central management location, single pane of glass that you can actually look into the fabric of what's going on. Okay? Any questions still now? Is this good?
I have one question.
Sure.
Specific with this design here, I know there's limitations with the latency.
Yes.
And it's 10 milliseconds or something. Is that something that over time is going to evolve to where it's not a requirement to be that low latency?
Absolutely.
Okay.
Absolutely, we are. There's a lot of work being done right now for on that exact configuration that's going to be coming out on the next virtual releases. So you can actually separate the fabric and still have a single management domain. Right now, available to you if you wanted to is what we call quasi-shared mode, where you can have two complete separate fabrics and then use a central location or tooling on the center that can push policies down to each one. Okay? So I don't know if you guys learned that, like the ACI toolkit and all that stuff that's being built to do it. So, but that's still two separate fabrics. But we are going to get to single fabric control policy between the two, separated by a none path, right? Yes?
From a scale-out perspective, how many locations could be in a stretched fabric at the moment?
Two.
Two. You're working on more, or it will be stay at two?
Yes, we're working.
Okay.
Absolutely. This product right now is what I would call completely non-stationary.
Okay.
It is like in 3 months, if you don't look at what's going on, you're behind. The amount of work that's going into it is incredible. So it's really evolutionary. So there's a lot of stuff, because this is not an NDA session, I can't talk about a lot of things that are going on, but I can tell you that, in a year, it's just, what I'm talking about here is gone, it'll be a new stuff, okay? But it's really cool. So right now, what I wanted to talk about is when we talk about that brown side of the house, right? When brownfield, and we're talking about how do we bring one data center into the other one, we get into various concepts. And I've presented on this topic, on this area a couple of times, because sometimes, all of us that have been doing networking for a long time, we look at the world in a certain way. It's like we're ingrained. We have VLANs in our heads, we have routers in our heads, we have everything is there, and it's like, hey, the ACI came in and now it's talking about EPGs, virtual domains, and all these other tenants. What is all this, and how do I marry it? And one of the things that I've done over the past months is to show this diagram here. Well, we have a traditional layer 3 environment, core distribution and access, right? You guys have seen that one before, right? Probably every day. And then you have this new fabric scenario in here. And how do we get these two together? How do we bring this world and join them in? And the reality, the solution is actually really simple. It seems hard at the beginning when you're trying to think about it, but it's actually very simple. So the first thing that you would do in this type of scenarios is literally connect into the world as an L2. We call a layer 2 connection from the outside, or in ACI terms, we call it an L2 external. Okay? And it's just simply you're bringing in a layer 2 domain into the fabric. That's all we're doing. Now, when you look at this, now you're going to be like, okay, whatever. What's so special about this? So inside, we start creating policies or application policies around this related to ACI. So you guys are familiar with the application profile? Okay. So application profile that contains verbs, the application profiles that contain the bridge domains, the endpoint groups, all structure of how things talk inside of ACI. Okay. That live inside of this tenant. Okay. So we actually then can go in, and by simply creating that external 2, we can start migrating external layer 2 services into the fabric. Okay? Now think about it, right? Right now you're looking at this, okay, we have a construct of an application profile defined in here. We're building it, we're associating this to the outside world. So we have some policy that's being built. But in essence, what we're saying is this: we're creating a very simple policy of this marrying to the outside world. So at this point in time, what happens is, from an L2 perspective, all the traffic is flowing in the network. It's simply going out as an L2 packet from inside of the fabric to the external side of the fabric. Okay? Very simple. And then from an L3 perspective, what happened? We still have our L3 located on the outside of the fabric. So when you think about it, all we've done now is like taken another set of rack of switches and played in the network, it's in an ACI, but we're still treating it just like it isn't. You know? So it's real easy to start bringing in. You can start bringing in devices in, connecting them into the fabric, so it's going to all have connectivity. Everybody's happy. So the next step on that stage is, and we start adding policy. Because one of the coolest things about ACI is the ability to insert services into the chains, right? Start bringing things in and start playing with that functionality. But at the same time, you're like, not exactly sure, you know, like in this case, I'm not exactly sure what this device in particular is going to talk to over here. So if I don't know what that device is talking to, it's kind of hard to put a firewall in between them. Correct? That's difficult. But now you start adding policy. I can start by simply separating them by different endpoint groups. Okay? Now an endpoint group in ACI is simply a policy domain. Right? I really, one of the things I always tell people is, please, you know, unmar yourself from thinking in VLANs. Okay? Because in ACI, putting an EPG as an equal VLAN will just hinder you. Right? An EPG is just a policy domain. It's just specifying, it says that these devices and these devices, how they can talk. That is all that they're doing. Okay? But the cool thing about it is once you get to this, now we can start getting into the play of inserting services in the path of those devices, if you wanted to.
Just for clarification,
Yes.
inside the ACI fabric, I understand how the flow would be working. Now from the L2 migration standpoint, yeah? All the servers that are still in the L2 domain that are outside would be treated like one big EPG. You cannot control the traffic that is between the servers, yeah?
This is one EPG over here, okay? This is another EPG in here. So while I still have my L3s outside, I start constraining around the EPGs in the fabric. So I can't apply policy between these two devices. So even though they're sitting outside the fabric, I can apply policy as they come in and out.
You can apply a policy if some server from the outside is communicating to the inside, but you can not do anything about communication between two servers that are still on the outside.
Over here? That's correct.
On the right side. Yeah.
If they're in the same endpoint group, then the policy that they live in is what they belong to.
Yeah.
But I can create more endpoint groups. And if I wanted to go over here and create policies between them, I can do that. Right?
You can do that for all the layer 3 traffic, for sure.
Or layer 2.
Okay.
If I wanted to create for example, I can create a one EPG for each one of these,
Yeah.
even though they are sitting on the same layer 2 domain.
Yeah.
And then I can specify how I want those to, what's possible for them to do, and we can control it.
Okay.
Right. I think what you're kind of going into is microsegmentation.
Yeah.
And microsegmentation is different, right? Because what microsegmentation talks about is how you can control a device that, even though they are on the same grouping policy, that you can microsegment them down there. And we can do microsegmentation to some extent, but I think what you're getting to is how our competitors do it, and there's a slight difference there. And I can get into a long conversation about why I don't agree, but that's fine, you know.
Okay.
We can do that later. All right. So, contract-wise, so what does that give us in the end? Where do we go from there? As this evolves and you start getting forward, one of the things that happens is all your devices now are migrated into the fabric. So let's suppose you get all the devices that belong to this particular network inside to the fabric. Well, why is their router now sitting outside? What's the point of that? Makes no sense, right? If these guys are sitting here and their network is sitting on the outside, their default router doesn't belong there anymore, if everybody's inside. So now we can do the process of migrating that guy in. We can bring them into the fabric by first creating an external layer 3. Layer 3, an external L3 is ACI's mechanism to actually promote or establish L3 connections or router connections to the outside world.
So layer 2, layer 3 on the transit leaves, right, or not?
On the what?
On the transit leaves. Are the transit
They
leaves
could be
there?
on anything.
Okay.
There's really no difference in ACI on the leaves. There's nothing. We do call them border leaves.
Okay.
In the way that we terminology speak to them about the architecture, we mention them as borders because they're talking to the outside. But from a perspective of ACI, we don't sell a border leaf, right? You can just pretty much, any of them, apply a policy as you wish. So once we get to that point and we actually get this in there, what happens is we can migrate that SVI into the fabric. And now we get full benefits of ACI by doing that, because now we can incorporate ARP suppression, anycast gateway functionality, meaning that every leaf will start answering for the policy that is on it. So if I have devices that are moving across my 20 or 30 leaf switches, wherever a device is that belongs to an EPG, we go to the leaf and we automatically instantiate the SVI for it. If it moves from one to another, we take it out. So we're very conscious about what's on the fabric because we know where everything is and we know exactly where we have to apply and put policies in place.
Just a quick question.
Yeah.
Which devices can act as a border leaf device? Any or?
Any.
Any, okay.
Yes. So you can apply the policy of your border leaf to any device in your fabric as you want. It just depends on which connectivity you're interested in, right?
Okay.
So L2 migration considerations. You guys worked with Spanish Tree before?
Not in the past 10 years?
No? Well, the only gotcha I'll tell you about this is, as you talk about this, is from a layer 2 perspective of migration, always remember ACI is a transport. We don't participate in spanning tree. We just transport BPDUs from one point to another. But always remember that we have to have association of what exit port we're going to send it to, because of course BPDUs, as they are transported, are encapsulated, have the VLAN tag inside of the PBSD packet, and those can't go around the wrong way, all right? So just one consideration there. So from external side, the external L3 construct is actually pretty cool because in the latest release in the ACI and Brazos, we now move to what we call a complete shared L3 out structure, meaning that we can put the L3 out into a common structure and start sharing that across all the different tenants of the fabric. Okay? Good? Questions? Yes.
When I start migrating, I suggest my layer 3 would be on the core layer, yeah, for example.
Okay.
And then I would start migrating it to the border leaf, yeah.
Okay. So what you would do is you have your layer 3 connection. So just imagine, right? The layer 3 connection is in essence like any other router, right?
Yeah.
So now you have some stub network in between the two, and you have a routing protocol, OSPF, gRP, BGP, whatever you want, talking between some, let's say the 7K here and this guy here, and they have a routing protocol. Now they're sharing networks. So these will get those, and etc. So if let me go back here to this. So now the external 3 comes in, and I learn a bunch of routes. And I know how to reach certain things in the network. And that's part of and pushed in, but it is relevant to the tenant that you are. Remember that ACI is a multi-layered environment. Sorry, not multi-layered, it's a multi-VRF, multi-structure, multi-tenant environment. So you can have thousands of VRFs. You don't know it, right? You just created tenants. And you said, okay, I got a tenant, I got a bridge domain. And if you didn't do anything, you just went the default route, you just created a whole different VRF. Now, that structure that's inside of the fabric, if you wanted to talk to the external, it needs to be tied. Okay? And that structure that you're tying through the outside is going to be done through what we call that external L3. So now, even though I have, let's say, that L2 going on, and I have traffic and everything flowing through it, I have this external L3, and I can still tie it back into that tenant if I wanted to. Right? Without a problem. And then as you progress, you can start bringing those subnets in. But I can't have 10.10.10 one subnet on the outside and go to here and say I have 10.10.10 one on the inside and also say I'm an advertisement. That wouldn't work in the regular world. It's not going to work in ACI, right? But you can in ACI, for example, have the 10.10.10 one address shared across, a couple hundred tenants in the private space. And it's perfect for them. That's fantastic. Then you can create a different structure for those guys to actually talk to the outside. Like if you want to do some ASA or something, provide a service to get NAT, etc. But from the external L3, as you're migrating into the ACI world, you would just create that L3. You can create it on the common side of the house and share it with everybody, right? And then every tenant tying into that external layer 3 and utilizing those resources and advertising you want, okay? Because the structure of the fabric is this way. So if you see inside of ACI, inside of the application profile, there's what we call the bridge domain, which sits on top of the endpoint group. Now, have you guys heard about the EPG equal VLAN? Right, and I earlier said that bad juju with that. I think the best to understand is when we say VLAN, the closest thing that you can put together is going to be the bridge domain and the EPG. It's those two things together. Because the bridge domain is the one that contains all the information that has to do with layer 2, right? The default gateway, etc. Now, the important here is that if I wanted to have something in the fabric and I wanted to advertise it out, we can trigger in each individual case, if we want that subnet to exist in the outside world, advertise in the outside world. So you can selectively say this subnet needs to go. I want everybody to learn about it. And once you do that from a migration perspective, now that subnet would get routed. And of course, the external world will be like, oh, okay, so I know that to get to this address 64.102.250.024, I can go through this route. It gets advertised just like any other route. Okay, and that's the migration process as we bring things into the fabric in itself. That's exactly kind of like it works. As you can see, I have not mentioned to you guys application profiles, mention any of that stuff. So what I'm trying to show you is you can actually put ACI out there without getting into the nuances of trying to create a policy structure around your network, right? Because that's not easy, right? That's not an easy thing to do. Especially in brownfield, you have applications that are there that have been there for years, and Johnny wrote this Java app over here and this guy over that, and they have all these different things, and then to know exactly what ports are open is more complicated. But with this mechanism, you can actually bring things in, and as time progresses, you can start migrating what you learn into policy world, okay? Meaning that you can be like, well, I know these two servers are my databases, and I know they're running my SQL. Well, let me go ahead and now take those servers and migrate them all into an endpoint group and create a contract between the other world and this world that says 3306, that's it. And now what you've done is you've created an ability to kind of isolate something or obscure it or hide it away and save it from being attacked from many other things. Right? You've kind of applied that policy in place. Okay?
How does the customer get visibility of what's happening? So assume like you've done the migration, you're now using the new infrastructure, but the model is pretty much the same. The networking model, okay, you've collapsed the layers, but you're still really operating, you call them endpoint groups, but effectively they're behaving like VLANs for policy.
Yeah.
So how do you analyze what's happening in your network to avoid needing to rely on documentation, etc., to actually build this profile that you need to put in all this policy?
Yes. All right. So the answer is, how do you build the application profile after you deploy it, if you do that, right? What visibility do we have in the fabric to it? There are things that you can do in the ACI fabric to see what's going on after things are inside, if you will. So there are tools that actually can show you tracking endpoints. There are tools that actually can show you, what's going on between the endpoint groups, traffic-wise. And there's also other integrations that we are actually starting to work on or now going forward to actually do very specific analysis of the traffic and give you that information, right? But as you can imagine, that some of this is rather complicated, right? Because once I start getting into, hey, well, we got all these 10 gig servers and we got all this stuff going on and 40 gig flows and everything happening, it starts getting kind of hairy really quick to be able to capture all that data. But expect some advertisement of new products from Cisco very soon that are going to start trickling in that space, including stuff like our acquisition of Landcope and all that good jazz. Okay. So again, from the external side, real quick, connectivity on the outside, we support OSPF, EIGRP, IGBT, UVC, and static routes. So that's kind of like what you can configure on that leg out, which is separate from what you advertise on the inside. Everything inside the fabric is once it comes in, it is learned. It goes inside the fabric as BGP, and it's advertised inside the fabric completely by BGP. Okay. The cool thing about it is you guys don't have to do anything. From your perspective, you just simply say, I have a policy that I want, and the only policy you have to define is the route reflector on the spines, and it's just a one little click box type thing, and now the routes are advertised down where they belong. Routes are also selectively placed on leafs where they belong, meaning that if you have one tenant that has 10,000 routes and you have another tenant that has 100 routes, but a tenant doesn't have anything on that leaf, those routes are not there. So we selectively know who is here, and we selectively know what policies we need to apply on that connectivity. Okay, so that's to save resources and control. The other new feature that came out recently in the 1.1 release was transient routes. So we can now actually not stub network it. We come inside of one, and we can actually take learned routes from one and advertise them out of the other one. Remember, from the perspective of this, we are actually redistributing. Any of you guys done redistribution of routing?
For sure.
How much fun is that?
Lot of fun.
I love it.
So much fun.
You love it? I know. I mean, everybody's done route redistribution. It's always like, woohoo! That's so much fun. No. But it's still there, and the good thing about it is that we take care of it for you. Okay, from the perspective of ACI, he manages that. There is a table on CCO that actually shows you exactly where those transients are, what we currently support going from one to another, because we don't support all from any to any. But from a perspective, little by little, as each release goes and more testing is done, more validation present, more we get out of that. And this also makes it possible to transient your network as you are doing a migration strategy. It actually gives you the ability to also, if you need, to advertise, networks from one side of the data center to another data center and bring them all together, marrying them out.